Hello and welcome guys. Now in this tutorial we will be looking at implementation of linear regression, and I will be dividing into two parts. First we will look at linear regression implementation without gradient descent and then with gradient descent, and it will be the both will be completely using plain Python code. We will not be using any library, so that for us it will be easy to understand as well as easy to explain and understand it clearly what actually happening inside the actual gradient descent function that sklearn provide us. Okay, so let's get started. So first of all, what we need to do is we need to import the numpy library. Okay, now what we will do, we'll create a class. Okay, so for this we will give the name as lr. Okay, class lr. Now we need to define the constructor. Okay, so the constructor will be def init. Here we will pass the self dot m. For now it will be none. Self dot p, again it will be also none. Okay, so this init constructor initialize two instance variable. First is self dot m, that is slope, then self dot b, that is intercept. So these variable will store the coefficient of the linear regression model. Okay, so now let's define another method, that is fit. Okay, so def fit. Here we will pass self, xtrain and ytrain. Okay, then we have to define numerator and denominator. Okay, now we'll run a loop for whatever the number of the rows we have. Okay, now we'll update the numerator, which will be numerator xtrain then it will get multiplied to ytrain. Then we will have denominator. Here we also again have to update it. Okay, so just copy it. Okay, now we just have to change this ytrain with xtrain, and let me explain what happening here. Before that, self dot m equal to numerator by denominator. Okay, now self dot so what actually happening here is this fit method is used to train the linear regression model, and it takes two argument, xtrain, the input feature, and the ytrain, that is the target values. Okay, so it compute the slope, that is self dot m, and intercept self dot d of the linear regression line using the least square method, and the calculation involves the numerator, which is num, and the denominator, that is den, for the formula to find the slope. Okay, so this is what is happening here, and the slope is calculated as the ratio of numerator and denominator, and the intercept is determined using the mean value of xtrain and ytrain. Okay, now what we will do, we'll create a predict method. Okay, def predict. Again here we'll take self and the test set. Okay, now it will return dot m self dot b. Remember the formula, that is what we are using here. Okay, so now let's run it. Okay, now what we need to do is we need to create our dummy data. Okay, so for that let's define an array. Okay, let's define y. Okay, now we need to split this data. Okay, and for splitting, so for the splitting data, what we will be using is trend test split function from Scikit-learn. Okay, so the the example data set that is created with feature x and target values y. In this example, the input feature represent value from 1 to 5, and the target value are roughly linearly related. Okay, that's why we haven't changed much. Okay, so now what we will be doing, we will be importing trend test split. Okay, so let's do that. So from Scikit-learn dot model selection, okay, import trend test split. Okay, now let's rerun it. Okay, now what we'll do, we'll split the data set into training and testing. Okay, so first of all, xtrain, xtest, ytrain, and ytest. Okay, and we'll pass the function trend test split. We'll pass our input and target. We'll pass our test size. So I will be creating another video, and I will explain the trade-off between test size and train size. Okay, why we choose 20% or 30% as the test size, why not 50% training, 50% test. Okay, so I'll explain that in the later video. For now, let's keep the test size to be 20% and the random state, okay, random state equal to 2. Okay, now what is random state? So I mean, in machine learning, the random state parameter is used to control the randomness or unpredictability of certain operation. Okay, so it helps us for several purposes, like reproducibility. So by setting a specific random state value, you can ensure that the result of machine learning experiment are reproducible. When you use the random state value, you will get the same random outcome in every run. Okay, so this is particularly used when you want to share your code or reproduce your experiment precisely. And if I run the whole code again and again, it will give same outputs. So for that reason, we set some random state, so that every time we run it, we'll get the same output, I mean more precisely same output. For that reason we do that. Okay, so hope this is clear. Okay, it's saying x not defined, let me rerun it. Okay, so now you can see we have defined our x train and all other sets. Okay, let's create the linear regression instance. Okay, so it will be lr. Okay, now what we will do, we'll fit the our regression model. Okay, so the fifth method of the LR object is called for training data, x train and y train, and this step basically train the linear regression model by calculating the slope and the intercept based on the training data. Okay, so fit x train, y train, and let's run it. So this is done. Now the only thing remains is the prediction. Okay, so let's predict it, y equal to, or you can call it ypred equal to lr dot predict our x test. So remember what we were having in the x test. Let's print it out. Okay, we have only one row, obviously, because it is 20% of the data set, because 5 out of 5, 20% will be one data point. Okay, so you can see that inside our x test we have one value, that is 3. Okay, so let's see what is the prediction, what we get, I mean, in the prediction. Okay, so let's print it out along with slope and intercept. Okay, let's copy it, intercept, then our predicted value. So let's run it. Now you can see our slope is 0.7, our intercept is 1.4, and the predicted value that we have got is 3.5. Okay, now if you ask me, let's say we have a random variable and I want to predict that, how we will be doing it? So for that we need to define our I mean the data set that you want to predict. So let's say let's name it new x. Okay, and it will be again np.array, and put your value, anything like 6, 7. Okay, and it should be in list. So what we will do next we'll do prediction. Okay, new prediction equal to lr.predict. Here we'll pass new x, and then we'll print our predicted value. Okay, so you can see that for 6 our predicted value is 5.6, and for 7 our predicted value is 6.3, and this is how we basically implement linear regression without gradient descent. And you can see, right, how easy it was. Same way, I mean, we will be implementing the gradient descent part as well. And again, I'm telling you, it won't be that hard to understand each of these concepts. So theoretically, when we see some mathematical expression, it sometimes it may be some confusing, but when we implement using Python code, it will be very easy to understand. So that's why practice is very important. Okay, so let's now implement the linear regression with gradient descent, so that we'll get to know how basically the existing code will differ from by adding a new line of code for gradient descent. So it will be similar, almost similar, but few lines of code will be added, because we need to minimize the error, right? So let's do that. Okay, and for that let's import some of the libraries. Same thing will be imported here as well. Now one more thing that we will be adding here, that is matplotlib, and the reason why we will be plotting the error. Okay, so let's run it. Okay, so let's first do generating some random data for demonstration purpose. So np.random dot seed. Now you understand why we are using seed, right? Okay, so we'll define our x, which will be 2 into np.random then our y equal to. So I'm trying to make sure all the data point are nearby each other. Okay, okay, so we have defined our x and y. Let's plot them and see how they actually look like. Okay, figure dot figure equal to plt dot figure. So let's define the figure size. Okay, and the plot type will be scatter. We have our x and y. Let's plot them now. So basically here what we have done is we have generated some synthetic data, and with the help of numpy to create random data point for the feature x and the target variable y. So the target variable y is generated as a linear function of x with some random noise added. Okay, so let's run and plot them. Okay, okay, you can see now, I mean both x and y are linearly close. Okay, and that's why I told you, I mean this term basically what it does, it should be uh, it is making sure that the all data point are nearby each other. Okay, so that is what we have done there. Now what we need to do is we need to split the training set. Okay, and for that, remember what we were doing, we were splitting the data set into 20 to 80%. Now let's copy that code here. Okay, x train, y train, and all of those. So here what we will do, we do not need x I mean the library, that is train test split function. Okay, from sklearn library, what we will do, we'll just take the 80 data point from there. Okay, because we have 100 data points. Okay, so it will generate 100 data points. Now what we will do is we will take 80 data points, and then remaining will be left for test set. So how we will be doing it, we will be doing indexing. Okay, so this way we will get our x train, this way we'll get our y train, x train, x test, y train, and y test. Now we have splitted our data set, so let's see how actually x test look like. Okay, so you can see that we have 20 data points here. I mean it should be 20 data point. Okay, so now what we need to do is we need to create our linear regression class. Okay, so let's do that. Now the very first thing we do is we should be creating the constructor self learning rate number of iteration. Okay, so let's say by default we will be setting it as 1000. Self.lr equal to lr self dot n iterations equal to n iterations. Okay, so and the next step is we will be creating our fit method, def fit. Here we will pass self x y self dot theta equal to p dot random. We need to define, remember we had to we should have some value to start with. Same way we are doing some random computation here, so we'll get some value and then we'll start the minimization part. So loss minimization. Now we'll run an iteration. Okay, for whatever the number of iteration we have. Okay, so we'll calculate the prediction equal to x dot theta. Okay, and error will be prediction minus actual. Okay, now gradient will be our x dot transpose dot length of y. We'll update the theta, will be minus equal to self dot lr into gradient. Okay, now our mean squared error will be np dot mean of error whole square and self dot loss history should append. Now we'll return the self. Okay, so this fit method of linear regression is used to train the model. So it initializes the model parameter theta with some random value. It iterates, iteratively updates the model parameter using gradient descent. It computes the prediction error and compute the gradient of loss with respect to parameters and updates the parameter accordingly. And then after that, the mean squared error is computed at each iteration and stored in loss history list to track the model training progress. Okay, now we will be working with predict method. Okay, and inside predict what we will be keeping is our x. Okay, so it will return self dot theta. So basically this predict method is used to make prediction for trained model. So it take the input feature x and return the predicted target variable based on the learned parameter theta. Okay, now what we will be doing is we will be preparing the data for training, and for that what we should be doing is we need to create some uh, you know training set. Okay, and let's do that. And this training set is prepared by adding the bias term, so a column of ones, so basically 1 1 1 like that, to a feature matrix. So this is done to account the intercept term in the linear regression equation. So you remember, right, in the PowerPoint we have seen our intercept we have defined around 0 like that. Now here we will be creating another column like a feature matrix column, and there we will keep our intercept as 1. Okay, and for that reason we need to create a matrix and we'll add the bias term. Okay, so let's say the variable name is xb. Okay, so np dot so this adds the bias term. Okay, so let's see our y train. This is how it will look. And then xb, you can see that we have added intercept. Okay, so hope this is clear. Now let's create the instance of our model. So model equal to linear regression lr equal to 0.01 and iterations equal to 1000. Okay, now what we'll do next, we will do the fit. Okay, and we will pass our new data frame with intercept. Okay, and our y train. It is saying linear regression not defined. Okay, so there is some spelling mistake, I guess. So this error shouldn't come actually. Why this is coming? And iterations. Okay, not defined. Let's make it s. Okay, sorry about that. Okay, here we haven't mentioned the self, and that's why the error was coming. Okay, now prediction is not defined. Okay, it should be including s. Okay, now you can see that our model has been trained. The next thing we will be doing is we will be making the prediction on test set. Okay, so let's do that. So x test b equal to once x test. So the way that we have inserted intercept in the x train set, we need to add it for x test set. Okay, and for that reason we are doing this particular step. Comma x test. Okay, so now our prediction has been done. Okay, to see, let's print it. So this is what our prediction is for our x test. Okay, now let's plot that training data and the regression line. Okay, and for that what we do is we'll use a scatter plot. Okay, color, let's take it as red. Okay, now plt dot show. Okay, so now you can see that this is how our data was looking, and this is the best fitted line that we have got from our model. And you can see that it's correctly in the middle of both the columns like x and y. Okay, so this is how a perfect model look like. Now let's see how our error plot look like, or you can say loss history. Okay, so loss history equal to model dot get loss history. Okay, this will give us all the numbers. Now plt dot plot range length of our loss history. And then our x label, which will be iterations, which will be our mean squared error, and then title. Now plt dot show. Okay, get loss history. Okay, let's define a method here, def get loss history. Okay, and this will return the loss history. Okay, now let's rerun that code. Okay, we need to define the instance again. Okay, let's restart the kernel. So again we have our linear regression with best fitted line. Now we'll see the loss, and as you can see that after reaching like around 100 iteration, it has already reached mean squared error of almost 0, and we can see that the model has been correctly predicting all the our data point, and hence you can say that the model is in a good shape. Okay, and this is how we basically implement linear regression with gradient descent, and you can understand, right? I mean, what the difference is. It's just these few lines. Okay, so these few lines only we need to add for gradient descent. Apart from that, earlier we were using just m and b, and then we were computing according to the equation. So now with the help of gradient descent, we are what extra step we are doing is we are iterating with the number of iteration that is given, and then we computing the error with the help of previous intercept, and we calculating derivative, all of those things, and then we are getting this correct generalizable model. Okay, so hope things are clear now, and in the next video what we will be doing is we will be covering up one whole project based on linear regression, and then there we will be using Scikit-learn linear regression, and we will be seeing how easy it is to implement using Scikit-learn library. So we don't have to write all this code. It will be just done with just 2 line of this code. So this is what the difference is. Now that's all for today. So thank you, have a good day.